Comets are a celestial mystery.
They are messengers from deep space itself, time machines from the early universe.
Comets could unlock the deepest secrets of our cosmos.
If we can establish a correlation between amino acids on comets and life on Earth, that would be one of the most significant findings in science.
They threaten our very survival.
We're talking about something the size of a mountain. So the amount of energy that this thing would release upon impact is devastating.
Yet without comets, we might not be here.
We may owe a great cosmic debt to comets because they may have been responsible for bringing the chemicals that we require for life to the Earth.
A dramatic streak of light across the sky, a passing comet, is an astonishing sight.
They're beautiful, these fuzzy glowing balls with the tail coming off. It's really something. You just don't get to see an object like that very often.
Comets are extraordinary. If you get to see a comet for the very first time, it'll stick with you forever.
The journey of a comet as it sails through the solar system is the most fantastic of all astronomical objects.
It loops in toward the sun from the depths of space, an odyssey that can last millions of years. Many pass by the Earth so often, they're almost like old friends. Every comet is a frozen mass of rock and ice several miles across. But all we see is a glowing ball of light and a long, sweeping tail. Yet comets are more than cosmic fireworks. They could help unlock some of the deepest mysteries in science.
We're trying to figure out as scientists where we came from, and that means everything from the beginning of the universe to the beginning of the solar system to how life started. Comets really fit into that. They really give us clues about how the solar system formed. If we can't understand comets, we don't understand how we got here.
Comets may even be the source of life itself.
We may owe our existence to the fact that comets billions of years ago came to Earth and brought the necessary ingredients for life.
They can also cause enormous destruction. Comets could kill us all.
If a comet were to hit the Earth, watch out. It would be a planet buster. It would be an object sufficient to wipe out all life as we know it on the planet.
Learn about comets, and just maybe we will learn how to survive them and begin to understand how the universe works.
When we study them, we're learning what the solar system was like when it was first forming, and we can learn about what other solar systems were like as well. And hopefully that will teach us a tremendous amount about how stars form and how planets form and how comets themselves were originally formed.
But the comets did not stay put. Several 100 million years later, the solar system plunged into turmoil once again. Encounters with debris pulled the gas giants out of position. The giants' immense gravity then hurled comets in every direction, flinging trillions of tons of material from the dawn of the solar system into the cold outer reaches of space. Some comets settled in a region 4,000 million miles from the sun, the Kuiper Belt. but most were tossed even farther out to form a giant sphere around the entire solar system. We call it the Oort cloud.
This is a region of our solar system that's farthest away from the sun. The sun is just a tiny little dot, one of many stars. And the whole area of space around you is virtually empty. There's nothing there, very little. And just occasionally you'll find the odd comet floating out there in deep freeze, cold, dark, and very much alone.
In this remote ice cloud, there are more than 1 trillion comets. They can take millions of years to orbit the sun. But they don't always stay here. The orbit of every comet is a delicate gravitational balance. The smallest nudge can tip the scale.
Most comets spend their entire lifespan billions of miles from the sun, motionless, inert, simply waiting for something to happen. But then, perhaps a random collision takes place. Perhaps a passing star nudges it, and then the gravitational force of the sun inevitably pulls it toward the inner solar system.
Gravity, the force that created the comets, then flung them to the edge of the solar system, now pulls them back in. Our comet begins its epic odyssey to spread life or death across the solar system. More than 1 trillion comets circle the sun at the frozen edges of our solar system. But many do not stay here. The smallest gravitational disruption can knock them out of their orbit.
It could be a nearby star going by. It could be us going through a denser part of the galaxy. Anything that just gives a little gravitational hit to a comet can cause it to fall in towards us.
Our comet has been disturbed. Now the sun's immense gravity takes over.
You can think of the gravity of our solar system sort of like being a hillside. At the bottom, there's the sun, and comets are way at the top of that hill. When they get dislodged, there's only one way for them to go. They have to fall down in towards the sun.
Our comet accelerates towards the sun, but its path is far from straight. Gravity from the planets can throw comets off course or out of the solar system completely. If they escape these obstacles, comets continue their journey toward the sun. Now they begin one of the most remarkable transformations known to science.
A chrysalis to a butterfly. They become the most spectacular things the universe has to offer.
As it passes Jupiter, our comet begins to change.
As it starts to move a little bit faster and starts getting closer and closer to the sun, and it starts feeling the heat of the sun, that's when things really start to change.
500 million miles from the sun, heat brings our comet to life. Frozen gases start to vaporize. Grains of ice and dust rise from the surface.
As the comet continues to approach the sun and gets warmer, more and more gas is released. The comet becomes a fuzzy ball. There's a solid part in there, but it's surrounded by a much larger sort of cloud of material.
This cloud of dust and gas forms an atmosphere or coma around the comet. And it also creates the comet's huge tail. It's all driven by the sun, and it's not over yet.
There's something called the solar wind. It's actually a huge wave of charged particles originating from the sun. This fills our solar system, and as a comet begins to move further and further in towards the sun, the solar wind gets stronger.
Like a cosmic hurricane, the solar wind blasts gas molecules from our comet out into space. they form a second giant tail.
The solid part of the comet might only be a few miles across, and the fuzzy part might be a few thousand or tens of thousands of miles across. The tail that gets swept back as that material is blown off by the solar wind can be millions or tens of millions of miles long.
Our comet hurtles through space at 50,000 miles an hour. It's about to enter the most violent phase of its journey. 200 million miles from the sun, water ice begins to vaporize.
The ground would start to shift and quake, and as the material beneath my feet is literally thawing, we'd have great big jets of carbon dioxide and water ice starting to come out. And that would not be a very good place to be standing.
The surface cracks open. Gases explode. Debris fires in all directions. The force of these eruptions makes the comet tumble erratically.
Every jet that turns on is literally like a little jet engine attached to the comet.
Like a dragster on a racetrack, our comet explodes to life. Incredible speed, irresistible energy, and a vast plume of debris. Our comet transforms into a cosmic hot rod, but speed and energy are a volatile mix. Our comet could blow apart at any moment. The cloud around our comet is now bigger than Jupiter. Its tail stretches for 100 million miles. An object 4.5 billion years old emerges from the dark.
Every arrival of a new comet is like a gift from the universe. We've never seen this little bit of the solar system before. This little building block, this little baby picture, it's completely new to us.
It's a chance to study the origin of our solar system. And what we're learning is a revelation. Comets are far more hostile and alien than we imagined. With modern telescopes, we can study comets in more detail than ever before. But to really understand them, we need to get close to the very heart of a comet, its nucleus.
One of the holy grails of comet science is to really understand what is in a comet's nucleus, what is actually on the surface, what is the chemical composition, what are the characteristics of the rocks and the materials, the volatiles that are on that surface.
The nucleus is the fundamental building block of the solar system that we as scientists really want to investigate. That's where the mysteries really are.
There have been more than a dozen missions to comets in the past 3 decades. Every one of them has been a revelation.
We've learned about the chemistry of them. We've learned about the physical interaction they have with the sun. We've learned about their physical surface, their terrain, and how they're different even if you were to go from one spot on a comet to another. So we're really learning that these things are worlds unto themselves.
Scientists thought comets were white, like a snowball. That changed in 1986 when the Giotto space probe beamed back these images of Halley's Comet.
For the first time in history, we had a snapshot of the very center of that comet that entered human history on many occasions, and we found a cold, dead world. We found an object shaped like a peanut.
Halley was no snowball. A thick layer of black dust covered its surface. There were pits and hills, and Halley was 9 miles long. far bigger than anyone expected. Scientists thought that all comets were the same. They were wrong. In 2004, the Stardust probe flew into the tail of Comet Wild 2 and captured thousands of tiny dust particles.
When Stardust brought those samples back on Earth, we realized that, in fact, every comet is a unique object. Just like every planet is different, it looks like every comet is different. It has its own history to tell. Different materials went into its formation, different heat sources were injected into its interior, different chemical processes and geologic processes occurred. Each one is a unique world waiting to be explored.
Some comets are truly strange. These are real images of Hartley 2, a comet so weird it snows.
It's so strange. We were able to see that there are golf ball-sized chunks of dry ice that are following the comet around up to 1 million miles away from the nucleus. This thing is just making a big mess.
Hartley 2 is just amazing. It looked like you were in the middle of a snow globe and you shook it up and there are all these little things, kind of like flies buzzing around food, just kind of floating out there. It's just not right.
Hartley 2 is a hyperactive comet. It tumbles faster and spits out more debris than most others its size. Comets are alien worlds. On Comet Tempel 1, there are smooth plateaus, craters and cliffs 60 feet high. Layers of rock lie on top of each other like a stack of pancakes. Each comet seems to have its own unique history. Tempel 1 gave scientists their biggest breakthrough. In 2005, the Deep Impact Space Probe slammed a projectile into its surface. The explosion dug out a crater 150 yards across.
Talk about a spectacular 4th of July. I mean, can you imagine anything better? We actually blew a hole in a comet. I mean, that's got to be one of the more amazing things that NASA has ever done.
The material the impact ejected allowed us to see inside a comet's nucleus for the first time.
It was completely unexpected. We found things like rubies and peridot, gemstones, tiny little things inside the comet. And we found all kinds of organic molecules, the very sorts of things we're made of.
Scientists now believe that comets play a critical role in our universe.
Where do the ingredients of life come from? Where were they all mixed together? Where did all this liquid water come from? Comets could hold the key to understanding the nature of life itself.
But opportunities to study them up close are rare. Our comet is now moving at incredible speed toward a place where no spacecraft could ever survive: the sun. "4 billion years ago, gravity hurled comets to the edges of our solar system. The same force can pull them back in. Our comet passes Earth and enters the most violent stage of its journey. It rockets toward the sun at 100,000 miles per hour.
The surface of the comet is now sizzling with activity. Blistering temperatures are being created. Enormous geysers of ice crystals and gas being shot off the surface.
Jets are erupting all over the place. It's tumbling, the rotational state is changing, and the very surface is kind of cracking up underneath our feet.
Inside the comet, pockets of gas explode and fling huge rocks into space.
It's losing mass, it's shrinking. And as we get closer and closer to the sun and more of the volatiles are starting to come off of its surface, this can actually change the rotational state of the comet. can make it tumble, can actually even push it in its orbit. It can actually change the orbit of the comet.
Comets can shed 50 tons of ice and gas every second. Enormous pressures build up inside the nucleus.
It could become unstable. It could even break apart into pieces at any time.
As comets reach their closest point to the sun, their existence is on a knife edge. Many will not survive.
We've been able to actually see images of comets just getting swallowed up by the sun. And you can actually see them just pelting in there, and the whole body, whether it's a mile across or 10 miles across, just gets completely and utterly destroyed.
A solar observatory recorded these extraordinary images. They show small comets called sun grazers diving towards the sun. Here they're exposed to immense gravity and torched by the ferocious heat of the sun. Many are vaporized. Even in deep space, vast explosions can tear comets apart. In 2007, Comet Holmes was heading away from the sun when something extraordinary happened. In less than a day, it grew 500,000 times brighter. The cloud around it ballooned into space.
It's actually relatively common for a coma, the fuzzy part around a comet, to expand large enough to be bigger than Jupiter, 100,000 miles across. But that can take days and weeks and months to build up. To have a single event, something that happened, boom, all at once, some catastrophe, to create this shell around Comet Holmes that could be bigger than Jupiter is amazing to me.
We had never seen something like this before. In fact, the coma of the comet was actually larger than the sun itself. Briefly, it was the largest object in the entire solar system, something that was unprecedented.
Without warning, Comet Holmes blew apart. The largest cometary explosion ever recorded. The debris stretched for 1,000,000 miles. What caused it is still unclear.
One theory is that perhaps Comet Holmes slammed into an asteroid of some sort, creating this gigantic mega flare in outer space. Another possibility is perhaps the comet was unstable, and perhaps there was an explosion caused by expanding gas and ripped the entire comet apart. At the present time, we simply don't know.
The life of all comets hangs by a thread. Our comet survives its encounter with the sun, but it's paid a price.
Its geography has been totally rearranged. Huge chunks, mountaintops worth of rock have disappeared. An object which could be perhaps 10, 20 miles across has lost literally hundreds, perhaps thousands of tons of rock and ice on its journey.
As our comet leaves the sun behind, activity on its surface subsides.
On its outward journey, a comet gradually begins to shut down. It becomes cooler, less active, the jets begin to turn off, the coma begins to blow away, and you're left with this little ball of ice and dirt.
It returns to the depths of space, dormant once again. But the sun is just one of many challenges. Comets must also survive the gravitational pull of the planets.
Our gravity is way too small to have any effect on this comet, but Jupiter is a very large planet. It has 300 times the mass of the Earth. If the comet passes within even a few million miles of Jupiter, that can change its orbit.
The consequences can be Across the universe, comets cause massive destruction.
They could be moving 50 or more times faster than a rifle bullet. And we're talking about something the size of a mountain. So the amount of energy that this thing would release upon impact is devastating.
But they're not always destructive. They have another side. Scientists believe they can shape entire worlds. This is Titan, the largest of Saturn's moons. It's the only moon in our solar system with a thick atmosphere. Rivers and lakes of liquid methane cover its surface. Titan was transformed by comets. Radar images reveal a moon shaped by a blizzard of comets that rained down over millions of years. Each comet vaporized when it hit, releasing gases from inside its nucleus. Gradually, they built up a rich, organic atmosphere and this strange liquid landscape. Comets turned a space rock into an Earth-like world.
Comets, in some sense, are the ultimate engineers of the solar system. Cometary impacts could give us the chemicals which give us the atmosphere, not just of Titan, but even perhaps the Earth itself.
So if comets have the power to reshape entire worlds, what part did they play in the history of our own planet? To find out, we need to get closer to a comet than ever before. We need to land on one. In March 2004, the Rosetta mission launched.
The Rosetta mission is named after the Rosetta Stone because just like the stone gave linguists the keys to the ancient language, we're hoping that the comet will give us the keys to understanding the ancient solar system.
November 11th, 2014 will be a landmark in space exploration. For the very first time, a spacecraft will touch down on the surface of a comet.
Previous missions to comets were basically flybys, and they basically give us tantalizing evidence that there was a greater mystery yet to be solved. Now we're going to land on a comet. We're going to be up close and dirty with a live comet streaming through outer space, and this is unprecedented.
Rosetta is around the size of a car. It's flying through space at 20,000 miles per hour. It's heading for this. A comet with a nucleus 3 miles wide, orbiting the sun every 6.5 years. A robotic lander will drop down to the surface, beginning the most detailed study of a comet ever attempted.
It's going to look at what the surface looks like. It's going to take samples. It's going to look at the terrain. It's going to be able to actually probe inside the comet and see what it's made of and how it's put together. We're hopefully going to learn more from this mission about one comet than we have about just everything we've known about comets for centuries.
Rosetta should answer some very simple questions.
Is it porous? Is it like a sponge? Is it like a bunch of tubes? Is it like a snowflake, you know, with this sort of fairy castle structure? These things will help us to understand how the heat flows within and maybe what causes certain portions of it to become a jet and other portions not.
But this is just the beginning. For an entire year, Rosetta will study the comet on its epic journey round the sun. Using technology so advanced, it mimics the 5 human senses.
We've got instruments that can see. We've got a kind of an ultrasound experiment, instruments that are the equivalent of your hands. So we'd like to understand everything possible about this comet's journey around the sun from when it's quiet to when it's at its most active.
But we'll have to get there first. Just to reach the comet, scientists must overcome enormous technical challenges. Rosetta must hit a target just 3 miles wide, traveling at 34,000 miles per hour. Landing on it will be even harder. Comets have very little gravity.
There's not anything that you know is going to pull you down to the surface. And there's no atmosphere, so you can't unfurl a parachute and just sail down until you touch down. You've got to figure out a way to get your lander to actually reside and rest on the surface.
Technicians have an ingenious solution. The lander is equipped with shock absorbers and a harpoon.
When it makes contact with the surface, at the same time, the harpoon will be released down into the substrate, and it will have prongs that will open that will prevent it from coming back up.
Rosetta will attempt to solve some of science's deepest mysteries.
We would very much like to know, why is it that Earth has liquid water, and so much of it, compared to any place else that we've ever seen? So how is it that the water got here? Now, there is a theory that says that comets delivered the water to the Earth long ago. But the question is, can we actually prove it?
To find out, the lander will collect water molecules to compare with water from Earth. But scientists hope to go even further. We're on the brink of making an extraordinary discovery. We may find proof that life itself has an extraterrestrial origin, that it was brought to Earth by comets. Life has existed on our planet for at least 3.5 billion years. But we still don't understand its beginnings. We used to think life originated on Earth itself, that volcanic gases and water vapor formed oceans and an atmosphere. Lightning added the creative spark for early life to begin. Now we think that's wrong, and the evidence is in space. In 1997, comet Hale-Bopp appeared, one of the biggest and brightest comets ever recorded. Scientists found it was packed with water, gases, and carbon, the basic ingredients for life. That discovery raised profound questions.
We're all used to the idea that life originated here on Earth, and it probably did, at least complex life. But where did the building blocks come from? Where did the water that makes up our body, the organic molecules that make up the very essence of life, they actually may not have been intrinsically part of the Earth to begin with. They came from somewhere else.
Hale-Bopp suggested that the raw materials for life might have an extraterrestrial origin. Since then, scientists have found further evidence. Astrobiologist Dante Loretta discovered that dust from comet Wilt 2 contained minerals that could only form in heat and liquid water.
We had the sulfide minerals, we had iron oxides, we had carbonate minerals, which are the same kind of materials that marine organisms use to build their shells, unlike anything we thought was possible to be formed in the early solar system.
Scientists have even found that comet Wilt 2 contains amino acids.
That's incredibly exciting because amino acids are the building blocks of proteins, and proteins are essential biomolecules for all life on Earth.
These discoveries have transformed our understanding of comets. Many scientists now believe they're more than just frozen time capsules. Perhaps they play a central role in the history of our planet.
We have learned from study of a single comet and the results of the Stardust mission that they are complex chemical laboratories where the ingredients of life could form. These materials likely did not arise naturally on the surface of the Earth from processes on our planet. Instead, they had to be delivered by these messengers from the outer solar system.
The idea that we may owe our existence to comet impacts is astounding, but not everyone is convinced.
There's pretty good circumstantial evidence that a comet might have been important to life. But we don't really have, if we're CSI, if we're the comet science investigators trying to prove it, we haven't got the proof lined up yet. It's quite possible that what we have out there has nothing to do with life as we know it on Earth.
Scientists hope the Rosetta mission will resolve the issue.
If we can establish a correlation between amino acids on comets and the amino acids we have on Earth, life on Earth, that would be one of the most significant findings in science.
The story of life on Earth began 4.5 billion years ago. When our planet formed, it was a barren, hostile world. 700 million years later, the solar system plunged into turmoil. Gravity ripped comets from their orbits and hurled them in all directions, many into the inner solar system. They rained down on the early Earth for 300 million years. They released gases and organic material, creating an atmosphere and the oceans. Finally, life could begin. It's a dramatic story. But is it true?
Only time is going to tell, if we keep studying these mysterious objects, whether or not we can really pin down exactly the mechanisms and find out how it all got started.
In 100 years' time, hopefully we'll look back and say, wouldn't it be cool to have been living at that time, to be a witness, to be one of the first to make these incredible discoveries?
In the meantime, the search for proof continues.
I can't say for sure if comets brought all of these raw ingredients to the Earth and that we evolved from these materials. But it's certainly possible, and it's absolutely poetic to think that we came from out there.